Solving polynomial equations that are in factored form using the zero product property. And the zero product property states that if A and B are real numbers, that A times B is equal to 0, then either A is 0 or B is 0. So we're going to make one of them 0, and we're going to solve for the other one. Today they're already going to be factored. As the week goes along, we're going to learn how to factor, and then we'll also learn how to solve these equations. So these are going to be in factored form already. So if we have an equation like this, we have two binomials. Let's say we have x minus 4, right, times x plus 1, right, and that is equal to 0. Right. Then what we will do is we'll set each of these equal to 0. So I'm going to take x minus 4 and set that equal to 0. And we're going to set x plus 1 and set that equal to 0. And when you solve these are the answers, or these are your roots of your quadratic. So this is going to be x is equal to 4. Here we're going to take a negative 1 to both sides, and x would be equal to a negative 1. Now I'm going to go back and I'm going to actually FOIL this, and we'll get x squared, all right, minus 3x minus 4. So when I FOIL that, I get that. Now I can take these numbers and see if they'll make it true. When I put 4 in there, I get 16 minus 12 minus 4. Does that equal to 0? And the answer is yes. So 4 works for this quadratic. And then when I put negative 1 in there, negative 1 squared is 1. Negative 1 times negative 3 is actually a plus 3 minus 4. Does that equal 0? And the answer is yes. So both of my roots, both of my solutions work. Now you get other situations that can occur. Let's say I get x plus 8. So there we got two roots, and we're going to square that. Remember, when something is squared, it means you're going to multiply it by itself. So in this case, I actually have x plus 8 times x plus 8, okay, and we're going to set that equal to 0. Now I don't have to solve both of these because I'm going to get the same answer. So I'm going to take x plus 8 and set it equal to 0. Well, what can I put in for x to make that true? And the answer is a negative 8. So this one only has one root, and it's a negative 8. And again, you can check that solution back in the original equation. All right, now the last type of problem we're going to have is going to be have three binomials. Let's say we have 3x minus 2, all right, times 4x plus 3 times x plus 4. Oops. All right, and it'll set that equal to 0. And so in a case like this, this is actually, again, a binomial times a binomial, which would get you a trinomial. And so this would be a trinomial times a binomial, which will get you a polynomial. More than likely you'd have a x to the third or maybe x to the fourth term in this polynomial. So now, same case here. We take each one of these. We go 3x minus 2 is equal to 0. We go 4x plus 3 is equal to 0. And we got x plus 4 is equal to 0. I'm going to do the easiest one first. This one's going to be x is equal to a negative 4. Over here, I'll have 3x is equal to 2, and therefore x is 2/3. And then the middle one, I'm going to have 4x is equal to a negative 3. When I divide by 4, x would be equal to a negative 3/4. So my three solutions to this are 2/3, negative 3/4, and a negative 4. So that is how you solve polynomial equations that are already factored.